In this section, we are going to create graphs out of slope-intercept form and interpret them. So keep in mind that slope-intercept form was y equals mx plus b, where b is your y-intercept, it's the ordered pair 0, b, and m is your slope. It is your rise divided by your run. So in our equation, we need to make a graph of y equals 2x plus 3. Our y-intercept, our constant, our b value is 3. So our graph will start at 0, 3. So y-intercept, 3. Our slope is 2, which as a fraction, we need a rise and a run. So that is 2 over 1. So I need to be rising 2. So I'm going to go up 2 because that would be positive, and I'm going to run 1, which is also positive, so I will go to the right. So I will start at the y-intercept, and I'm going to rise 2, run 1. Rise 2, I'd be off the graph, run 1. Well, 2 points is not enough to draw our line, so somehow we need to end up with points on the back side of our line, so we need to flip both of our counting directions. So 2 divided by 1 is positive 2, but negative 2 divided by negative 1 is also positive 2, so it would be an equal slope. So I can rise negative 2, which means down 2, and I can run negative 1, which would mean I need to go left 1. So I go back to my y-intercept. I'm going to rise negative 2 and run negative 1. And you'll see that my dots are starting to make a straight line together. If I would have accidentally gone down 2 and right 1, I would have started to get a V shape, and V's are not linear. So we need something that's going to be a perfectly straight line. So I can keep counting down 2 and left 1, down 2 and left 1, down 2 and left 1 until I'm out of space. And because this is not a story problem, it's just a plain old math problem, we're going to make a continuous connected graph because we could put decimals and fractions in for x if we wanted to, and there would be our graph. So we started at the y-intercept and we counted out the slope, and we reversed the slope direction to get the other side of our line. Consider 2x plus 5y equals 10. How does this equation look different from slope-intercept form? So remember, slope-intercept form is y equals mx plus b. So the major glaring difference between y equals mx plus b and 2x plus 5y equals 10 is that x and y are on the same side of the equal sign. So it doesn't start with y equals. So it's not in slope-intercept form. However, we can rewrite it so it is in slope-intercept form. And to do this, we need to solve for y, or we need to get y by itself. So our goal is to end up with y sitting right there still, and everything else moves to the right side of the equation. So we'll start by moving the 2x because it's just being added. So I subtract 2x on the left, and I'll subtract 2x on the right. The 2x's will cancel on the left, and I'll have 5y equals, and I'm going to slide the negative 2x in front of the 10. The 10 is positive, so it'll be plus 10. And we're still not done yet because it says 5y equals and not just y equals. This is 5 times y, so to undo that, I would divide by 5, and if I divide the left side, I have to divide the whole entire right side. The 5's will cancel each other out, so I'm left with y equals, and then I have some division to do. I have negative 2x divided by 5, so I can just leave that as a fraction, negative 2/5 x, and I can do 10 divided by 5, which is 2, so plus 2. Now I'm in y equals mx plus b form. y equals mx plus b. The slope is negative 2/5, and the y-intercept is 0, 2. So when I go to make my graph, I start at my y-intercept. So I go to my y-axis, count up 2. There's 0, 2. Now I need to count out my slope. So negative 2 over 5. So I'd have to rise negative 2 and run 5. So rising a negative means I'm going to go down, and running a positive means I'm going to go to the right. So starting at the y-intercept, I'm going to go down 2 and right 5. So I went down 2 spaces and right 5 spaces, and now I'm out of room in my graph. So I'm going to have to work on trying to get a point back here so I can get a third point. So I'm going to switch my signs. So instead of having negative 2, I'm going to have a positive 2. Instead of having positive 5, I'm going to have a negative 5. So I'm going to rise positive 2, which means going up. I'm going to run negative 5, so I'll go left. So I'm going to go up 2 and left 5. And my 3 dots should be collinear. They should make a perfectly straight line together. If I did not correctly flip the numbers, the signs on my slope, and I accidentally went up and right, I would have gotten a V shape, and I would have known immediately something was wrong. So there's the graph of y equals negative 2/5 x plus 2. Let's try another one. Graph the equation negative 4x minus 5y equals negative 10. Why don't you try to solve this so that you can get it in the form y equals mx plus b. So take a second and try that. The first thing that you're going to want to do is move the negative 4x to the other side. So add 4x, add 4x. This 5 is negative, so bring down the negative 5y equals, I'm going to slide the 4x in front of the negative 10. So last time I put a plus sign here because the 10 was positive. This time I'll have subtraction because the 10 is negative. Still not done because y isn't by itself. So that's negative 5 times y. So I'm going to divide by negative 5 on both sides. The negative 5s will cancel. Y equals 4x divided by negative 5 is 4 over 5. And I need a negative, so negative 4/5 x. Negative 10 divided by negative 5 is positive 2. What do you think the y-intercept is? What's the slope? So the y-intercept is 0, 2. The slope is negative 4/5. So I'm going to start my graph with putting a dot at 0, 2. I'm going to count out my slope. I'm going to rise negative 4, so I'm going to go down 4. I'm going to run 5, so I'm going to write 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Again, I'm out of space. I can't continue to count that way. So I'm going to flip my signs. Currently, I have a negative 4 and a positive 5. So I'm going to make it a positive 4 and a negative 5. So if you punch negative 4/5 into a calculator, you'll get negative 0.8. If you punch 4 divided by negative 5 into your calculator, you'll also get negative 0.8. So they're equivalent to each other. Now I'm going to rise 4, so go up 4. I'm going to run negative 5, so I'll go left. Go back to my y-intercept, count up 4. 1, 2, 3, 4, and left 5. 1, 2, 3, 4, 5. So I have down 4 and over 5, and I went up 4 and left 5. The 3 points seem to be collinear. They make a straight line together. And this should be all of the points that work in the equation negative 4x minus 5y equals negative 10. Let's see what we learned. We have line T We have triangle ECA, and triangle FBD, all on the same coordinate plane. Which of the following statements are true? Select all that apply. The slope of AC is equal to the slope of BD. So is the slope from A to C the same as the slope from B to D? Well, from A to C, we would rise 1, 2, 3, and run 1, 2, 3, 4, 5, 6. So that is rising 3, running 6, which is a half. And the slope of BD, we would rise 1, 2, and run 1, 2, 3, 4. So the slope would be 2 over 4, which is 1/2. So the slope of AC is equal to the slope of BD. Yeah, well, a half is equal to a half. The slope of AC is equal to the slope of line T. Well, here's AC. It is part of line T. Since line T is linear, it has a constant slope. So the slope is the same whether I look from here to here, here to here, here to here, here to here. The slope is the same for the whole line. So yes, this part of AC, which is part of line T, should represent the slope. The slope of line T is equal to EC over AE. Well, EC was 6. AE was 3. 6 over 3 is 2. This is our slope upside down. So this was run over rise, and we need rise over run. So no, that one's out. The slope of line T is equal to BF over FD. So BF is 2. FD is 4. So 2 over 4 is 1/2. Yes. The y-intercept of the line is 0, 2. So the line crosses the y-axis at 2. So yes. Line T represents a discrete function. So remember, discrete means dotted. Discrete is dotted. We definitely do not have a dotted graph. We have a continuous connected line. So this is not a discrete graph. So discrete graph would be dotted, meaning your x value was things you were counting and you would not be able to use decimals and fractions for x. And we have a solid line. So it's not discrete.